today's video is going to be a review on the angle relationships and segment relationships within a circle. So sometimes our picture can look very similar, except for one's going to be dealing with segments and one has to deal with angles. So it's really important that as you approach each question, you're looking and you're asking yourself, okay, am I dealing with angle measures or am I dealing with segment lengths? And that will kind of steer you towards which direction you should go. We look at number 1, and I can see that I'm dealing with angle measures. I see that I have degree markers on those numbers. The first thing that I notice is that the vertex of this angle is going to be on the circle. When it's on the circle, that is an inscribed angle, and that means that the angle measure is going to be half of the arc length. So because I'm given the angle, I'm going to double that. So 2 times 48, and I find that that arc is going to be 96. Our job is to find the measure of this portion of the circle. We think about in a circle, the whole circle has 360 degrees. So I take 360 minus this 110 right here, minus the 96 that we found, and that's going to leave us with whatever's left over, that x amount. So 360 minus 110 minus 96, we find that x is going to be 154 degrees. Number 2. All right, so number 2, I'm looking here, and these don't have degree markers. These are segment lengths. This is a chord-chord relationship. Chord-chord relationship. And the chord-chord relationship is piece 1 times piece 2 equals piece 1 times piece 2. So if I look along this chord, that is 5 times 8. And then my other chord is equal to 4 times x. I'm multiplying the two pieces along the same chord together. So 5 times 8 is going to give me 40 equals 4x. We divide by 4 and we find that x is going to be equal to 10. Number 3, we're switching gears again. I see all of my numbers here have angle measures. Remember this one, our first one, our vertex of our angle was on the circle. When I look over here, the vertex is going to be in the circle. So when I see this, I'm looking at the intercepted arcs. And when our vertex is inside of the circle, it is arc 1 plus arc 2 divided by 2 is equal to that angle on the inside. So 41 plus x cut in half is equal to 58. Remember, these are those intercepted arcs. Now my x is over here within that fraction. So what I want to do is I want to get rid of this fraction. To do that, if I'm dividing by 2, I'm going to multiply both sides by 2. That cancels those. So we have 41 plus x is equal to 116. 58 times 2 is 116. We move that 41 over, and we find that missing piece there. X is going to be equal to 75 degrees. So this missing arc right here is 75 degrees. Moving on. Number 4. A couple different ways, but when I look at number 4, I see its angle measures, and that vertex is on the circle. And when I follow those up, we actually have a couple different ways we can approach this. I notice that I have a chord that goes through the center. That is your diameter. That is half of the circle, which means that this is 180. Because this is half of the arc, we take that and cut it in half. That means that this angle right here is going to be 90. We can think about it that long way, or there was a shortcut that we learned, theorem that we learned about that. So we know that that inscribed angle right there, 6x plus 15, when it intercepts the diameter that way, it's going to be a right angle. We move that 15 over. 6x is equal to 75. We divide by 6, and we find that x is going to be equal to 12 and a half. Number 5, oh, we got angles again, so 2 angle problems in a row. When I'm looking at this, I see my vertex is coming from the center. So there's a difference between it being on the inside and it coming from the center. When it comes from the center, this is the same as this. Unfortunately, we don't know what that arc is. What I'm given is that this much of my arc is 234. So we go back to the fact that our whole circle is 360. That portion is 234. So when I take that away, I'm left with 126. So that much right here is 126. When it comes from, again, the center of the circle, this angle and that arc is the same. So x is 126 degrees. Number 6, okay, now we're switching it up and we're going to segment lengths. This is a secant relationship because it's going through 2 spots. This is your secant relationship. And if you remember, it's outside times whole, outside times whole. So if I look at the top portion, the outside is x, the whole is x plus 8. And then on the bottom portion, the outside piece is 3. The whole piece is 13 plus 3, which is 16. We distribute in our x, so that gives us x squared plus 8x. 3 times 16 is 48. We are going to have to factor here, so I move that 48 to get that 0 product property. Remember, when we are factoring, it has to be set equal to 0, and we're looking for 2 numbers that multiply to the outside and add to the middle. It has to fit both of those criteria. So if I'm multiplying to a negative number, I know 1 is positive and 1 is negative. Since I add to a positive 8, I know the bigger number has to be a positive 8. So I think about all the different ways I can multiply to 48. 2 and 24, 4 and 12, 8 and 6. But the winner is going to be a positive 12 and a negative 4, because 12 times negative 4 is a negative 48. 12 minus 4 is 8. So now I have 2 possibilities. X plus 12 gives me a negative 12. X minus 4 gives me x is a positive 4. But when I go back to my diagram, x is this segment length. Segments cannot be negative. So the winner is x is equal to 4. Next row. Number 7. We have a secant on top because it's touching in 2 spots. And then we have a tangent on the bottom because it's touching in 1. So this is a secant-tangent relationship with segment lengths. Remember in the last problem, the secant is outside times whole. So that's 2 times 16. And then the tangent piece is the tangent piece squared. Oops, look at that mistake I made. I wrote down 18 up here, but I accidentally wrote 16 here. Let's correct that real fast. So the outside of 2 times the whole of 18. So 2 times 18 is going to give me 36 equals x squared. We square root. Remember, that gives me plus or minus 6. But the same thing as last problem, this is representing the segment length. So x can't be a negative 6. So we have x is equal to a positive 6. Number 8, we have angle measures this time. And notice how number 8 is looking very similar to number 6. See that secant line, and in number 8 I've got a secant and a secant. So this is what we were talking about in the very beginning. Sometimes our pictures look almost identical, But in number 6, I had segments, and in number 8, I have angle measures. And when I have angles and arcs, I'm caring about where's that vertex. My vertex is outside of the circle. When that happens, those lines are creating intercepted arcs right here and right here. And that's your big arc minus the small arc cut in half is equal to the angle measure. So 202 minus 74, that gives me 128. I cut 128 in half, and I find that x is going to be equal to 64. So very different than how we did number 6. Our last one here, this is an extension of our inscribed angle theorem. When I'm looking here, this vertex is on the circle, and as I follow that up, the intercepted arc is right here. So if that's 65, I multiply that by 2, and this arc is 130. When I go to the other side, this is also on the circle, and when I follow those sides out, I notice that it has the exact same intercepted arc. So if I were to cut that in half, I notice that that means these angles have to be congruent. If the angles have the same intercepted arc, those inscribed angles there are going to be congruent. That was an extension on our inscribed angle day. So to solve this, we have 5x minus 30 is equal to 65. We move our 30 over. 5x is equal to 95. And when I divide 95 by 5, I find that x is equal to 19. All right, so that is going to be everything for the reviewing of angles and segments in a circle.